Right, this is an induction problem involving functions. So please don't get that little f there confused with Fibonacci. This is not Fibonacci. We just happen to use the little f. So the little f with a little subscript, f1, f3, whatever, that's Fibonacci. Unless otherwise stated, you might see in another class it's used for something else, so you need to know from the context. For this one, the little f here is for a function. This is a function from the natural numbers to the natural numbers. This function has this little property. It just happens to have this property that, let's see, f, you could do something like this. You could say f of 5 is f of 2 plus 3 is f of 2 plus f of 3. That's just something you could do. It just has this property, this funny little property, this additive property. All right, but that's not the statement P of n. This is the statement P of n. And later in parts B and C, we'll use this property to help us with our induction. There's a problem very similar to this. It's slightly easier than this one in the worksheet. So I'm doing the harder of the two. All right, so P of 0, right, there's P of n. So P of 0, you replace the n with a 0, and that's it. Right, so that's the thing I've been trying to get across about these problems that are like this, or these parts, part A, is that there's hardly any thinking involved. If you're thinking, you're definitely thinking way too hard. You shouldn't be thinking on these. You should just be replacing n with whatever is here. Okay, so this one we have 0 times x, f of 0 times x equals 0 times f of x. Let me get rid of those. P of k, replace the n with a k, f of kx equals k f of x.